What's more impressive? A supercomputer trained on billions of words, or a laptop-sized AI that outsmarts it with only 8,000 examples? HRM is that second one, and it didn't just match today's biggest models, it crushed them in benchmarks like Sudoku, mazes, and even abstract reasoning tests. The crazy part? It doesn't need mountains of data, it has a whole new way of reasoning. Let's break down why this could be the biggest shakeup in AI since Transformers. Why are trillion-parameter eyes still tripping over basic logic puzzles? That's the question a lot of people are asking right now, because on paper the biggest models should have solved reasoning ages ago. OpenAI keeps scaling up, Anthropic throws massive clusters at the problem, and Google's stacking terabytes of scraped data on GPUs. The theory has been straightforward. More data plus more parameters equals more intelligence. Except when you actually test them on plain reasoning, the results don't really line up with the hype. Think about it this way. You give one of these billion-dollar models a Sudoku board, and instead of working through the rules, it starts generating long chains of text about possible numbers. It looks like it's thinking out loud, but what it's really doing is rambling. Half the time, the digits don't line up or the rules get broken halfway through the solution. Chain of thought prompting was supposed to make the models more logical, but in practice it's more like a guess stretched across a paragraph. You end up with a fancy-looking explanation that still gets the puzzle wrong. And it's not just Sudoku. Mazes, simple math, even those find the pattern tests you'd expect a middle schooler to handle can throw these massive systems off. The paradox here is that scale delivers fluent language and endless trivia, but it fails on tasks that need step-by-step consistency. That's where HRM comes smashing through expectations. Instead of billions of parameters, it's running with just 27 million. That's tiny compared to GPT-4, but its reasoning accuracy is higher. It's like watching a compact car zip through lanes while an 18-wheeler lumbers behind, stuck in traffic and unable to turn fast enough. Now, here's why that actually matters. The big model playbook is getting too expensive. Training costs are climbing into hundreds of millions of dollars, the hardware requirements are exploding, and regular people never get to run these systems locally. If every year bigger meant better, maybe that would make sense. But we're hitting a wall where more scale isn't solving the thinking problem. And once you realize a small, efficient model like HRM can sidestep that wall completely, it shakes the whole "bigger is smarter" narrative that's been driving the AI arms race. The bottom line is this. Those trillion-parameter monsters are incredible at spitting out paragraphs, but when it comes to following strict reasoning paths, they stumble. HRM proves you don't need brute force to think, you need structure. And that's what makes it so disruptive. It doesn't just guess once and hope for the best, it uses a process that looks more like actual reasoning. We'll get into how that system works in a second, because that's the real secret behind its shocking results. What if an AI didn't just guess once, but planned, checked itself, and tried again? That's the idea behind HRM, and it's a pretty big reason this model feels different. Instead of doing the usual transformer thing, spit out the most likely next word, it's built around two modules that bounce ideas off each other. Think of it like a tiny brain with two sides, a planner and a worker. One sets the strategy, the other does the grunt work, and they're constantly looping so mistakes don't just slip through. Traditional transformers don't really have that second layer of awareness. They're more like sentence finishers. Give them a prompt and they extend text by following statistical patterns. That works great for trivia questions or casual conversation, but when the task involves multiple steps that need to be checked along the way, the system doesn't pause to ask itself, did that move actually work? It just barrels forward. HRM works differently. It pushes decisions through a feedback loop where each step is tested, then re-evaluated before moving on. The planner is the slow thinker. It lays out the structure of the task in broad strokes, almost like sketching a game plan before attempting a move. Instead of guessing the answer straight out, it breaks the problem into smaller sub-goals, like find entry routes, test possibilities, or lock in partial solutions. Then the worker steps in. The worker is fast, trial and error oriented. It carries out those sub-goals one at a time, putting the ideas into action. If the worker fails, that information goes back to the planner, which tweaks the next strategy. The cycle keeps repeating until the model hits on a consistent solution. Imagine trying to solve a digital maze. A transformer will push tokens until it outputs something like go left, go right, go down, but it won't recognize if that leads into a dead end. HRM instead runs the worker through one possible route, checks if it works, and if not, the planner adjusts directions. That back and forth correction is closer to how people try paths, recognize mistakes, and keep refining their approach until they succeed. The amazing part is that HRM isn't locked to a fixed number of cycles. It can run the loop longer on more complex challenges, say, a 30 by 30 maze that needs dozens of attempts, or shorter if the problem is simple. That flexibility is a big part of why it doesn't waste resources but still nails tough puzzles. So the core difference is HRM isn't just an autocomplete machine. It's a miniature agent that evaluates, retries, and builds a strategy on the fly. It treats reasoning like an iterative process rather than a one-shot guess. And when you see how this plays out in real benchmarks, it becomes clear why a small model can outperform massive ones that were never designed to actually think. That's where the results get pretty shocking. Numbers don't lie. So how does a model with only 27 million parameters crush giants like Claude and GPT on reasoning tests? That's the part that made researchers double-check their scores. On the ARC-AGI benchmark, which is basically a test of how well an AI can solve novel pattern problems, HRM clocked in at 40.3%. For context, Claude sat at 21.2, and OpenAI's smaller GPT-based model hit 34.5. You'd expect the huge labs with billion-dollar models to mop the floor, but the little guy landed on top. Now think about what that means. The models with the most data, the most parameters, the most marketing, they ended up being outscored by something that can literally fit on a laptop. In AI benchmarks, that sort of upset feels like watching a high school chess champ beat a grandmaster. It exposes how fragile the bigger is smarter assumption really is. And the shock doesn't stop there, because when you move beyond ARC into tasks like mazes, the results get even harder to ignore. When tested on 30 by 30 labyrinths, HRM solved them more than 70% of the time. That's not "oh, it made some progress." That's it actually found working solutions to large, complex puzzles where every step needs absolute accuracy. Meanwhile, some of the billion-parameter models ended with 0% success. That's right. Billions of parameters on cutting-edge infrastructure, and they couldn't walk through a simple maze. HRM, on the other hand, kept testing paths, revising strategy, and finishing the job. And then there's Sudoku. We all know it's a clean test of logic. You can't bluff your way to a solution when a single wrong number breaks the whole board. HRM scored a 55% success rate at solving difficult Sudoku problems. Claude and GPT-level models? A flat 0. You can almost see how the architected loop between planner and worker modules gives HRM an edge. It doesn't just blurt out candidate numbers. It actually tracks rules and updates decisions along the way. Even more surprising is how light the training workload was. Instead of scraping the entire internet and burning through terabytes of text, HRM trained with only about 1,000 examples per task. That's lean enough to train in hours rather than the weeks it usually takes big models. It's targeted learning, not brute force memorization. And that efficiency is what makes its success so hard to ignore. If you can build a model this good with a fraction of the resources, what does that mean for the future economics of AI? There are already demos outside of puzzles that point toward rapid, practical use. HRM has been tested on rare disease diagnosis and climate forecasting, and in those fields it's hitting over 97% accuracy. Suddenly you've got an open-source model that can match specialized medical software or scientific simulations. On paper, this shouldn't be possible, but HRM delivers it in a framework light enough to run on consumer hardware. So we're looking at a smaller, sharper, faster strategy for AI. And if a laptop-sized model can outthink billion-parameter bots, it raises a bigger question. Where does this leave the race toward AGI and the next generation of AI agents? Alright, so here's the big takeaway. Maybe the future of AI won't be built on trillion-dollar server farms but on smarter designs like HRM instead of piling on data. It shows how architecture can reshape what machines can actually do. That flips the entire race on its head. Now picture this running on your phone or a household robot. Would you trust something that actually reasons before it acts? That's the shift HRM hints at. Not heavier, but lighter. Not locked in labs, but accessible anywhere. A glimpse of AGI that feels a lot closer than expected. So if you found this breakdown helpful and want to stay ahead of the curve as AI keeps evolving, make sure to hit subscribe and turn on notifications. I'll be covering the latest breakthroughs and what they really mean for you. Thanks for watching, and I'll see you in the next one.